If this force weakened by just 1%, the universe would collapse. No galaxies, no stars, no atoms, nothing. It's not gravity, it's not electromagnetism, it's something far more intense. And yet, almost no one talks about it. So what is this invisible glue holding reality together? And how close have we come to unraveling it? You're about to find out. Let's begin with a journey inward. Zoom past galaxies into molecules, and even deeper into atoms. Go past the electrons and straight into the core, the nucleus. Hidden inside, we find the strongest force in the universe. Not somewhere out in deep space, but right at the heart of everything around you. Inside that nucleus, protons, each positively charged, are crammed together. Normally, like charges repel. They should be flying apart with incredible force, and yet they're locked in place. Why? Because of something extraordinary, the strong nuclear force. It's like a super-powered glue that binds protons and neutrons together. It's stronger than gravity, stronger than electromagnetism, and almost 1 trillion times more powerful than gravity. But this force has a quirk. It only works at insanely small distances, smaller than a single proton. Go just a little beyond that range, and it disappears completely. This microscopic scale makes the strong force nearly invisible, but its impact absolutely essential. Without it, atoms couldn't hold together. No atoms means no stars, no planets, and no life. Think of 2 protons trying to push away from each other, only to be yanked back by something you can't see. That's the strong nuclear force in action. Quiet, hidden, but holding reality together. As one physicist put it, it's the invisible hand that keeps matter, matter. Now that we understand how it works inside atoms, let's take a step back, way back to the very beginning. Imagine the universe just moments after the Big Bang. Everything is wild, hot, chaotic. Particles are flying in all directions. But in that cosmic storm, the strong nuclear force starts doing its work. Protons and neutrons begin sticking together. Hydrogen nuclei form. Then helium. This bonding, powered by the strong force, becomes the foundation for everything that comes after. Without it, stars wouldn't ignite, and without stars, you wouldn't get fusion. Without fusion, there are no heavier elements, no carbon, no oxygen, no iron. In other words, no Earth, no us. Here's where it gets crazy. The strength of the strong nuclear force had to be incredibly precise. If it were just 0.5% weaker, protons and neutrons wouldn't stick. No helium, no chemistry. If it were 0.5% stronger, hydrogen would have infused too quickly. Stars would burn out almost instantly. The universe would be full of radiation and explosions, but no stable structures. We live in a universe that's tuned to perfection, balanced at the edges of chaos. This force didn't just show up, it showed up at exactly the right strength to allow life to exist. A theoretical physicist once said, "The universe dances on the edge of nuclear perfection." So next time you gaze at the night sky or take a sip of water, remember, none of it would be possible without that tiny force playing its perfect part. But what if that perfection didn't exist? What if we messed with just a little? Let's say the strong nuclear force weakens by 1%. At first, it might seem like nothing has changed. But deep inside atoms, chaos begins. Protons start to repel too strongly. Nuclei lose their grip. Matter begins to fall apart. Without stable atoms, stars can't form. No nuclear fuel, no heat, no light, no chemistry. The entire periodic table collapses into nothing. Now let's flip it. Strengthen the force by 1%. Suddenly, fusion reactions race out of control. Stars ignite and die in moments. The universe becomes a war zone of violent explosions and toxic radiation. Nothing survives long enough to evolve. In either scenario, life never gets the chance to happen. This is what scientists call the fine-tuning problem. The universe only works because the strong nuclear force is exactly what it is. Some believe that this level of precision hints at deeper meaning, a design, Others propose that countless universes exist, each with slightly different values, and we just live in the rare one that works. Whichever way you lean, one truth is undeniable. The existence of everything depends on this force doing its job perfectly. To really grasp how essential the strong nuclear force is, let's compare it to the other fundamental forces of nature. There are 4 of them: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. Gravity is the force of attraction that keeps planets in orbit and galaxies spinning. It's powerful over long distances, but relatively weak. Electromagnetism makes electricity flow, powers your smartphone, and lights up the sky during storms. It's all around us. The weak nuclear force is responsible for radioactive decay. It's how the sun converts hydrogen into helium over billions of years. But then there's the strong nuclear force, the heavyweight champion of them all. It doesn't work over long distances. You can't feel it or see it. But without it, none of the other forces would matter, because the very structure of matter wouldn't exist. Imagine the universe as a building. Gravity is the framework. Electromagnetism handles the lights. The weak force keeps the plumbing running. But the strong force? That's the concrete, the thing that makes the building possible in the first place. It may not be flashy, but without it, everything collapses. Now we're getting into the really strange part. Unlike the other forces, the strong force doesn't play by the same rules. You can't isolate it. You can't even directly measure it in the way you can with electricity or gravity. It works through tiny particles called gluons, which act like messengers between quarks, the building blocks of protons and neutrons. Try to pull 2 quarks apart, and something bizarre happens. The force doesn't weaken. It strengthens, and instead of breaking free, the energy used to pull them apart creates more quarks. This leads to a phenomenon known as quark confinement. No one has ever observed a single quark. They're forever trapped in groups, bound together by the strongest force in existence. And it gets even stranger. The strong force operates using something called color charge. Not actual colors, but a kind of code that quarks must follow. Only certain combinations are allowed, which keeps everything in perfect balance. It's like a cosmic rulebook etched into the smallest components of matter. The strong force doesn't just bind particles, it enforces order. So let's come full circle. If this force weakened by just 1%, the universe as we know it would vanish. No stars, no chemistry, no matter, no life. The strong nuclear force isn't just powerful, it's precise. It's hidden, and it's absolutely essential. Most people have never heard of it, but it's working right now, inside every atom in your body, silently holding your entire world together. So the next time you hear someone talk about gravity being the most important force in the universe, stop them. Tell them the truth. The strongest force, the one keeping the universe from unraveling, is something almost no one talks about. And now that you've heard of it, what else might be hidden beneath the surface, quietly holding everything in place? Subscribe for more eye-opening science you won't forget. Let's explore the invisible together.